Okay, dear students, we are going to define the construction of matrix. Okay, we have to define the matrix construction. Actually, according to the definition of the matrix, a rectangular array of rows and columns is called matrix. That means, simply, we have to arrange the rows and columns is called a matrix. Okay, that's why number of rows into number of columns is called order of the matrix. Suppose we have to take m rows in the matrix and n columns in the matrix, then m by n or m into n is read as m by n is called order of the matrix. Okay, that's why from this construction of the matrix, various types of matrix define various types of matrix by this construction of matrix. That's why all the matrices definitely depends upon the construction of the matrix. The types of matrices actually: singleton matrix, a matrix which contains only single element, then the matrix is called singleton matrix. And rectangular matrix, in the matrix which contains number of rows not equal to number of columns, then the matrix is called rectangular matrix. Square matrix, in the matrix which contains number of rows is equal to number of columns, then the matrix is called square matrix. And row matrix, a matrix which contains only single row is called a row matrix, or it is also called horizontal matrix. Okay, and column matrix, a matrix which contains only single column, then the matrix is called column matrix, and it is also called vertical matrix. That's all. Like these are the more number of various types of matrices depends upon the construction of the matrix. Various types of matrices depends upon the construction of the matrix. Okay, that's why we are going to construction of the matrix. Okay, we have to define the construction of the matrix. Actually, representation of the matrix. Here, two open brackets or two square brackets or two vertical bars. So these are the representation of the matrices. That's why these matrix represents capital letters A, B, capital letters. So these are the representation of the matrices where represents capital letters. Okay, capital letters. Matrix represents capital letters. Now elements in the matrix represents small letters. Example, suppose let's capital A, we have to take the matrix, then A11, A12, A13, A14. That means here is first row. So this is A11 means this is the element in first row, first column. This is the element in first row, second column. This is the element in first row, third column. This is the element in first row, fourth column. Now A21, A22, A23, A24. So this is second row. Now this is the element in second row, first column. This is the element in second row, second column. This is the element in second row, third column. This is the element in second row, fourth column. Here it is A31, A32, A33, A34. Now this is the third row. So this is the element in third row, first column. This is the element in third row, second column. This is the element in third row, third column. This is the element in third row, fourth column. That's all. That's why this is the matrix of order 3 by 4, 3 into 4, which contains 3 rows and 4 columns, which contains 3 rows and 4 columns, right? Now examples. Suppose we have to write examples. Capital A. Okay, capital A, this is the matrix. Capital A. Here it is 5, 6, 7, 4, 5, 9. That's all. This is the matrix which contains 2 rows and 3 columns. That's why it represents 2 by 3 matrix. And capital B, we have to take 2, 5, 6, 7, 3, 9. So, which contains 3 rows and 2 columns. That's why it is 3 by 2 matrix. Another matrix we have to take capital X is equal to A, B, C, I, O, U, I, O, U, and E, F, G, E, F, G. That's all. This is another matrix. That's why the matrix represents capital letter and elements in the matrix represents small letters. That's why capital X is equal to, which contains 3 rows and 3 columns. That's all it is, 3 by 3 matrix. That's why here number of rows not equal to number of columns from these two. That's why these two rectangular matrix. This is number of rows is equal to number of columns. That's why it is square matrix. Square matrix of order 3. Right? That's all. Now we have to do the question on this concept. That means we have to do the question on the construction of the matrix. Now, question on this. Question. Construct the matrix. Construct a matrix. Construct a matrix. Construct a 2 by 3 matrix. Construct a 2 by 3 matrix whose elements are given by Aij is equal to 1 by 2 mod 2i minus 3j. 1 by 2 mod 2i minus 3j. That's all. This is the question construction. From this condition, we have to identify the 2 by 3 matrix. We have to find the matrix of order 2 by 3. That means now required matrix which contains 2 rows and 3 columns. Now observe, this is the element in the matrix. This represents element in the matrix such that Aij means this is the element of ith row, jth column. Now required 2 rows and 3 columns. That's why now required matrix A 2 by 3 means what? Which contains 2 rows and 3 columns. That is 2 rows and 3 columns. A11, A12, A13, A21, A22, A23. That's all. So this is the required matrix. This is the required matrix. Now we have to identify all the elements. Here from this formula. A11 means where I is 1, J is 1. Then 1 by 2 into I is 1, 2 into 1, 2, minus J is 1, 3 into 1, 3. That's why 2 minus 3. Mod 2 minus 3. Actually, mod 2 minus 3 is minus 1. That means 2 minus 3 is minus 1. Mod minus 1 is positive. That's why it is 1 by 2. And A12. Here it is 1 by 2 into 2 minus 6. 2 minus 6 is minus 4. Mod minus 4 is 2. Mod minus 4 is 4 plus 4. 2 minus 6, 4. So 4 by 2 is 2. Now A13. Here it is 1 by 2 into 2 minus 9. 2 minus 9 is minus 7. Mod minus 7 is plus 7. That's why it is 7 by 2. Again, to find A21, that is 1 by 2. 4 minus 3. So that is 1 by 2. Again, A22, 1 by 2 into 4 minus 6. That is 2 by 2, 1. And A23, 1 by 2 into 4 minus 9. 4 minus 9 is minus 5, but mod is there. That's why plus 5 by 2. Plus 5 by 2. That's all. All these values input this matrix. Now the required matrix is A is equal to, which contains 2 rows and 3 columns. A11, what is that? 1 by 2. Next 2. Next 7 by 2. Next 1 by 2. 1, 5 by 2. That's all. Now this is the required matrix of order 2 by 3. So construct a 2 by 3 matrix whose elements are given by Aij is equal to 1 by 2 into 2i minus 3j. So according to the question construction, this is the required matrix. That's why construction of the matrix is very, very important for competitive exams also, like J mains and advanced. So since some related questions, mixed conceptual questions also depends upon this matrix construction of the matrix. Are you clear? That's why once again, listen all of you. These brackets represents, the matrix represents, actually matrix denoted by capital letters, involving the elements in the matrix denoted by small letters. Okay, involving the elements in matrix denoted by small letters. That's why various types of matrices definitely depends upon the matrix construction. That's why construction of the matrix also depends upon the number of rows and columns according to the given condition. Here what is the condition? Aij is equal to 1 by 2 into 2i minus 3j. That's why that is depends upon the relation between I and j, since I represents the rows and j represents the columns. Are you clear? That's why. So Aij is equal to 1 by 2 into 2i minus 3j, where Aij is the element of ith row and jth column from the matrix. So according to this condition, we have to find the rectangular matrix or square matrix or singleton matrix or any matrix that depends upon this condition, since definitely the construction of the matrix related to the number of rows and number of columns. That's why here according to this 2 by 3, here this 2 by 3 now required matrix which contains 2 rows and 3 columns. That's why here 2 rows and 3 columns. Since this is A11, first that means the element in first row, first column, element in first row, second column, element in first row, third column, This is element in second row, first column. This is element in second row in second column. This is element in second row in third column. That's why, which contains 2 rows and 3 columns. So this is the construction of the matrix from the given condition. Okay, that's all. Right.